Welcome to watch our Smart Garden video 2. This video serves as a supplementary material of the first video. Please watch the video 1 before starting this video. Thank you. In the first video, we have presented project overview and architecture, demo of most of features, team member contribution and areas to be improved. In this video, we will talk about every features in more details, and every feature level will be shown on the top right of the slide. Easy, intermediate, or advanced. The member who did the feature will make explanations, including cloud service setup, coding logics, API implementation. We have also included some scenario simulations, and last but not least, reflection. We hope through this video, the audience can have a deeper insight of our project without missing any small feature. Hi, I'm Jiang Lei. Now I will be presenting the first bonus feature we have in our Smart Garden project. Besides using Raspberry Pi to set up hardware, we have made use of Arduino as well. And here is how we declare the pins of sensors and actuators. And inside the setup function, we specify the sensors as input while the actuators as output. And we use analog read syntax to read data of soil moisture and LDR values. To make the life easier for our users, we have set some of actuators to be auto-controlled. When the soil moisture is more than 500, the red LED light will be auto-turned on to alert the user by using this if-else statement. And for the LED, we use digital write syntax, as the LED can only read 1 or 0. If the room is very dark, the yellow LED light will be auto-turned on as a supply of light for the plants. We have also filmed a very short demo to visualize this feature. Hi, now let me to demo for you how does our Arduino auto control works. So, as you can see from here, the red and yellow LED light is off now, as we put the soil moisture sensor in the water, which is very wet. And now let's put it in a dry environment, the dry soil. And you can see that red LED light is auto on. So, how does the yellow LED light works? So now, let's off the room light. The room becomes darker now. After a few seconds, the yellow LED light is auto on by itself. Now, let's on the room light and see what happens to this LED. The yellow LED is off now, since the LDR detects enough brightness for the plant. After the setup, we then use serial to fetch data from Arduino. Since the data is in the string data type, we strip and convert them into float data type before making use of them. And then, we display the real-time data on the LCD screen, which is set up in the Raspberry Pi. It's just a basic feature.
Now I'll be talking about new features added in CA2. We are able to identify valid NFC card and customize buzzer sound. To identify valid NFC card, add in the valid tag serial number here. This is the serial number of Jiang Lei's card. Then we use if statement. So if there is a card detected, we use a for loop to check whether the card matches the valid card serial number. If the card is valid, the username Wonder Woman will be printed and a buzzer with customized sound will be triggered. Otherwise, the card will be identified as a guess and the buzzer will make a different sound. If no card is detected, the system will just print a no card message. And in the Python side, if the card is detected, no matter it's valid or not, the welcome message with the username will be displayed on the LCD screen. Now let me demo how the customized buzzer sound works. If you tap a valid card on the card reader, you'll hear a beep sound from the buzzer and a welcome message will be shown on the LCD screen. However, if you use an invalid card, you'll hear another sound from the buzzer. We have also included a sending WhatsApp message feature by using Twilio API. Firstly, go to your Twilio account and copy down your account SID and authentication token. Next, paste it in your AWS PubSub file. After that, go to your Twilio again to set up Sandbox for WhatsApp by adding your Sandbox number into your contact and send join with white to the Sandbox WhatsApp. If there is a valid card, the user will receive a WhatsApp message. Here is the codes.
So right now I'll be talking about send alerting email using AWS SNS. Firstly, go to SNS service and create a new topic. The name will be sensor moisture. Display name will also be sensor moisture. Under the topic, create a subscription. The protocol will be email. Endpoint will be an email address that can receive notification from Amazon SNS. Under IoT call, create a new rule. The name will be sensor moisture rule. Select an action which is send a message as SNS push notification. Under the push notification, select the SNS target. It will be the topic created earlier on, sensor moisture. The topic name will be sensor moisture. Afterward, go to AWS PubSub data file, subscribe to sensor moisture. If the soil moisture level is more than 500, a message will be published to sensor moisture topic and the user will receive a notification email that is registered. So right now I'll be talking about alerting Telegram message using AWS SNS and Lambda. Firstly, we will go to search for Lambda service. On the create function, create the function name which is daily alert, and the runtime will be Python 3.8. For the function code, we would like to establish the connection from Lambda to Telegram, and we will need two variables which is token and the chat ID that will be generated while creating the new Telegram bot. For the environment variables, we will need the key values which is chat ID and token. For the chat ID value, it will be user chat ID. Token value, it will be Telebot token. After creating the Lambda function, ARN URL will be auto-generated. It will be used for SNS endpoint. Right now, go to AWS SNS and create a new topic. Under the topic, create a subscription. The protocol will be AWS Lambda. Endpoint will be the ARN URL that was generated earlier on. Afterwards, we will go to IoT call and create a new rule. Under the new rule, we will configure the action, which is the SNS target that is created earlier on. The topic name will be sensor light. Afterward, go to AWS PubSub data and subscribe to sensor light. If light value is below 600, publish a message to sensor light saying there is not enough light for the plant the light level value is, so that this message will be sent to the user's Telegram. So right now we'll be creating the database for our project using AWS Dynamo database. Under Dynamo database service, create a table. The table name will be Smart Garden and input the partition key and sort key. Under IoT call, create a new rule. The topic name will be Smart Garden Data. After that, repeat the previous step to create the following three tables.
To insert data into DynamoDB, we need to subscribe to the topic in the AWS PubSub file. In this case, the topic is smartgarden/data. After that, add in these codes to the same file to publish it to the database.
And this is how the database looks like. Now I will be presenting one of the main features in our project, Control Water Pump. Users are able to control the water pump in our web interface with these two toggle buttons. There are 4 modes to select: Auto, Manual, On, and Off. Now let's see how it works. In the index.html file, a function which can set an AJAX with URL routes API/change status/ a parameter of the status selected by user will be triggered if the user changes the status of the water pump. And then, in the server file, this API will call a function setStatus in the Dynamo database file. This function is able to insert a new record into the status table. Here is how the table looks like. Okay, now the user command is set and stored in the database. So how does this MAOF command control the water pump? Inside the AWS PubSub status file, which is run when the system starts working, we subscribe to the database topic SmartGarden status table, and then query the latest command inserted by the user, and send the status to the Arduino site where the pump set up. In the Arduino file, it would read in the data using serial once it's available. So, if the status is auto control, the system will check the current soil moisture level. If it's more than 500, which means the plant is very dry, the pump will start running, and we use the analog rate for the water pump, where 220 is the speed of the motor. And if the status is manual control or off, no matter how much the soil moisture is, the pump will not be activated. And if the status is on, the water pump will just run without checking the soil moisture level. And we have filmed a demo with 4 scenarios, which has been included in the last video. So if you are interested, can watch it again. This function is a bit complex, but still doable. And since I have implemented in my CA1, I only identify it as an intermediate level of feature in the CA2. Now I will be talking about the most advanced feature in our project, which incorporates Telebot, AWS Dynamo database, 2 Raspberry Pi, Twitter Developer Service, AWS Recognition, and AWS S3 service. Let's see how it works. By using the Telebot, multiple users could share the same Telebot service with different chat ID. It will be useful for our targeted users that more than 1 family members want to take care of the house plants. And with these features, users can enjoy the following services: taking picture of plant or flower, or detect the bugs. The token of bot is set up in my Raspberry Pi Telegram script file. Once receiving a command, it will firstly identify the sender based on the chat ID and then perform functions based on the command. In the first scenario, a command plant is received. Since my Pi camera is set up to capture the picture of the plant, it will simply activate the Pi camera and take a picture of the plant. Afterwards, send a photo message back to the user. So what if the user send a message to request a picture of other plants such as flower? In this case, I need to set up one more camera for the flower. Therefore, I set up Jorin's Pi and use her Pi camera to capture the flower. However, only my Pi can receive the bot command, as the Telegram token can only be run at one time. So how can I trigger the Jorin's Pi camera use my Pi? Firstly, I configure the AWS IoT MQTT client as Lay pops up on my Raspberry Pi with valid credentials, and then subscribe to a new topic Telegram take picture command. If the command is a flower, my Pi will publish a new message with the payload flower to the topic. And in Jorin's Pi, I configure the IoT MQTT client as Jorin pops up, which is different from my Pi, but with the same credentials file. After that, I subscribe to the Telegram /take picture command topic. Once there is a new message publishing in this topic, Jorin's Pi will receive it. And if the message payload is a flower, Jorin's Pi camera will be triggered and the taken picture will be uploaded to the AWS S3 bucket. And the file name is always temporary picture, which means it will be overwritten again and again. And this is the temporary picture uploaded to the Amazon S3 service on the Smart Garden Wonder Woman bucket, which is created by me, and under flower folder. So after publishing the message to trigger the flower camera, my Pi will then download the file from the S3 service with the file name temporary flower and save it locally. Afterwards, the image will be sent to the user's telebot. And we have filmed a short demo which simulates a real-life scenario to explain how can this feature help our targeted user.
Oh, I'm currently right now on a business trip. I'm so worried for my plants. Oh, but I have a smart garden system that enables me to send a command to Telegram to take a picture of my plant right now. Command send.
This is Jorin's home, and this is her plant.
Oh, photo received.
Yeah, this is a real-time photo.
Now I'd like to take photo of the flower. It's taking picture of the flower now.
This is Jorin's flower.
Oh, the photo is taken.
Yeah, so this is a picture taken just now. The taken pictures are not only sent to the user through the Telegram, but also uploaded to Twitter. Firstly, we import the TP and paste the consumer key and secret and access key and secret to the file, and then set up the API. After that, we will publish the message with photos to the Twitter account saying that the plant or flower is uploaded by the user we identified based on the chat ID. The demo of this feature has been included in the last video. You can check it there. Now I will present the last but the most advanced feature in our project, which is detecting bugs. It is a continuous feature from the last one that the user send detect command to the telebot. The detection will be performed 5 times for both plant and flower using for loop. Let's look at the detection of the plant first. For the plant, just Pi camera will take picture of the plant and call the plant detect function. Since we are using AWS recognition service, we have to upload the file to S3 storage before I can perform the detection. And in this list, we have prepared a few items for the bug detection, such as insect, honeybee. And we used for loop to check whether the detected labels are inside the list. If it's not, the uploaded picture in the S3 storage will be deleted. Why? Although it's a small project, we still do not want to waste the storage in the cloud. However, if there is a bug detected, it will call a function in DynamoDB file to insert a new record into PIC-URL table. With the picture name in the S3 storage, user who initialized the detection and detection time. And this is how the table looks like. Now, let's see how the detect flower function works. Different from the plant, firstly, we need to publish a new message to trigger the Joris Pi camera to take picture of the flower and upload to S3 storage as a temporary picture file. And then we will call the flower detect function. Instead of uploading the local picture to S3 storage, we can just use the uploaded temporary picture in the S3 storage to perform the detection. And if the camera captures a bug, this temporary file will be downloaded to the local and uploaded to the S3 again with valid file name. I did this way since I didn't find any way to modify the file name in the S3 storage. Afterwards, it's the same as a plant detect function that inserts a uploaded bug picture name with a user who initialized the detection and the object type, either plant or flower, to PIC-URL table. And we have filmed a short demo to simulate the real-life scenarios to explain how can this feature help our targeted user. Hi, I'm Jiang Lei. My mom asked me to take care of the plant and flower, but now I'm not at home. I'm so worried. Is there any bug on the flower or plant? Oh yeah, I have a smart garden system. I can simply send a command to the Telegram. Detect. The smart garden photo assistance will help me to detect is there any bug on the flower or plant.
Oh, I'm a fly. On Jiang Lei's plant, let's see if the camera can detect me.
Oh my god, my plant is detected with a bug. And I received a photo of this bug. Now I start worrying for my flower. Is there any bug on my flower now?
There isn't any bugs on Jiang Lei's flower.
It seems okay, cause now it's detecting the flower for the first time. The second time also okay.
Right
Now
now,
it's performing the third time detection.
right now there's a bug on Jiang Lei's flower. Let's see if the camera can detect.
Oh, I received a message saying that my flower is detected with a bug. Please be alert. And this is a bug picture. The detection is completed. Wow, this smart garden system is so useful for me. And this is a screenshot of the chat between me and the teleport where I performed the detect feature during the video shooting. And we have an extension feature that users are able to view the bugs on our web interface, where he can monitor the bug condition of the plant and flower remotely and visually. We use the table layout for this interface, where the table row is auto-generated based on the number of records in the database. and the maximum number of the records is set to 9. One thing I want to highlight here is we used S3 URL to set the image source. To achieve that, we set the permission of the Wonder Woman bucket as public access so that the image could be displayed on the web server. We identify this whole entire feature as an advanced feature since it incorporates a few cloud services and it requires many logics. Although there are only 2 Pi cameras, the concept of this feature could be further implemented in the bigger project with more cameras. So this is the end of the video, and to conclude, our system is able to help family with plants and flowers using our auto watering system and bug detect function. Thanks for your watch. Have a nice day.